Okay, good afternoon, guys. Here's the video for U6L3. So the things we're going to look at today are the graphs of sine x and cosine x, and we'll also bring back the ideas of transformations and apply those to these two specific trig graphs. So hope everybody's doing well. I'm recording this after an email went out saying that we won't start classes until April 13 now, so we really hope we'll see you guys soon. Hope most of all that you're doing okay given all the circumstances. All right, let's get into the notes here. So this first page, nothing really important here. I'm just going to skip that. Okay. First big idea, what does the graph of y equals sine x look like? So we've got Desmos that made it already. We've got some important characteristics here. I'm going to go through all those first and then maybe write on the graph a little bit. So first thing to note is the period of this graph is 2 pi. Okay, trig graphs are unique in the sense that they have this repetitive pattern, and so the period, right? The period is the distance in the x direction that it takes, takes for the graph to repeat, okay? So if we look at this graph, it starts at 0, 0, it starts at the origin, and then right when it gets here, which is at x equals 2 pi, the whole pattern starts again, right? So this part here is the same as this part here, and so that pattern starts over again. So the distance that took in the x direction, well, from 0 to 2 pi, that's what we call the period. All right, the amplitude. So what amplitude is, it's the distance from what I call the center line up to either the top. So this is, y equals 0. That's going up to y equals 1, so that's an amplitude of 1. Or you could also say it's the distance from the center line, which again is at y equals 0, down to the min, y equals -1, okay? But it's a distance, so it's always positive. All right, this amplitude is never going to be negative. One other way to think about it is you could say it's the max value of 1 minus the min value, which is -1, divided by 2. Okay, so that's what I'm going to write. But if you think of it using the center line idea, that's fine too. So I'm going to say this is equal to the max minus the min over 2. All right, and I guess, hey, maybe I can just do this. That's the amplitude, okay? And this, yikes, ugly attempt at a line, that's the period, okay? What else do we have written here? Max function value is 1. Yeah, we know that. We'll get to where that occurs in a second. The min function value is -1. That occurs there. So I'm just going to plot a couple points, right? And this is going back to unit circle. So hopefully we know at 0, the sine is 0. The place where the sine has a maximum is where on the unit circle you're going straight up. So in radians, that's pi over 2. Okay, so that's that point right there. The sine becomes 0 again if you go straight left on the unit circle. So that is at pi. Right, so if I draw my unit circle over here, I have that's 0, that's 1, this is 0, this is -1. The sine is equal to the opposite over the hypotenuse, which is really the y value. Okay, so then this minimum, right, at -1, well, that's going to occur. That min value is going to occur right here. That's, if we spin around the unit circle, it's at 3 pi over 2. So this point is 3 pi over 2, -1. and then we come back to 2 pi 0. Why is that? Well, if I start at 0 and I rotate one full rotation around the circle, I'm at 2 pi, right? And now if I start rotating again, I'm just going to go through the same pattern as I had here. Okay? The range, well, that's the y values, right? So the range of this sine function is -1 to 1, and the domain is all real numbers, right? Because x is a angle. There's no angle that we can't sort of compute a sine for. All right. Cosine, similar in some of its characteristics, but you know it's a different looking graph. So it has the same period, it has the same amplitude, the max value is still the same, the min value is still the same, the range is still the same, and the domain is still the same. Okay, but the key here is you know, it starts at a different place and its behavior is different at the start too. So if I draw my unit circle again, right, and let's try and draw a triangle here. So if that's my angle, x, this is the adjacent side, this is the hypotenuse. That's really how I get cosine values. And in the unit circle, we're going to just say the hypotenuse is 1. Okay? So at 0 degrees, or excuse me, 0 radians right here, well, I'm there on the unit circle, the adjacent and the hypotenuse are the same. So the ratio of those is 1. So cosine starts at the point 0, 1. Okay, as I rotate up, and remember, I'm talking about cosine values, so I'm talking about the adjacent over the hypotenuse. At pi over 2, well, the adjacent side is 0 because they're going straight up, right? So this point right here is pi over 2, 0. Okay? If I continue rotating around to pi radians, well, that's 180 degrees. The cosine there is -1 because I'm moving left, which indicates a negative x value. So right here, this is the point, this is where the min is, this is the point pi -1. Okay? If I rotate around to 270 degrees, 3 pi over 2, well, the cosine there is 0 again, because I have no adjacent side, I'm going straight down. And if I go all the way over to 2 pi, the cosine is 1 again. So if I fill in these points, this is 3 pi over 2, 0. And this right here is 2 pi, 1. Then I've got one full cycle of the cosine graph, and after that it's gonna continue to repeat. Okay? Transformations. So this is basically a review from earlier units, right? There's a bunch of stuff we can do graphically just by adjusting the formula, right? So negative f of x, well, if you put a negative in front of the whole function, right, it reflects about the x-axis. If you put a negative just in front of the x in the formula, that will reflect the graph over the y-axis. Okay? Adding at the end of the formula or adding something to the whole thing, that's a shift up or down. Adding directly next to x, adding or subtracting, that's going to be a shift left or right. And if we multiply by some constant, right, it's going to be a stretch or compression. It just depends on how. So if you multiply the whole function by a constant, you'll have a vertical stretch or compression, which is kind of shown here. If you multiply just the x, then you have a horizontal stretch or compression. All right? That should be a review, but it's worth revisiting because it's gonna be very important in making these trig graphs. All right, so I think we have two examples. I'll actually stop this first video now. Let you start to look at this example, sine 2x. This example, 3 sine pi over 6 x minus 4 minus 1. That's a mess. And I'll make a second video going through how to do these.